This is Josh White with JW Math Tutoring. Today's video is going to go over two additional problems from the August 2024 Digital SAT Math exam, in addition to some alternate solution methods to problems that I previously covered from both the August and October 2024 exams as well. So let's go ahead and get started.
But life is a dream that calculus could never predict.
This video is going to have two additional problems that I had gathered from the August 2024 Digital SAT Math exam. I hadn't gone over them previously because I was trying to, basically get some more problems together to make a whole separate video. But I was only able to basically find two more problems. So I was just holding off on them. And someone had specifically requested the first problem in one of the comments in one of the other videos. So I thought that I'll just go ahead, do these two problems, and then after that, go through the basically alternate solutions to problems from both the August and October 2024 Digital SAT Math exams, basically suggested by commenters on the channel. Okay, so this first one is basically a system of equations problem dealing with sodium chloride. And what you have is two different solutions being mixed together, added together. And I'm just going to call the first one X and the second one Y. X is the 3%, Y is the, or 0.3%, excuse me, Y is the 0.15%. So together, we know that when we add them, we get a total of 60 grams. Right here, 60 gram solution. And we know that the overall final solution in it will have 0.12 grams of sodium chloride. So the second equation I set up is going to equal 0.12. And this is just going to be adding together the number of grams of sodium chloride from each solution together and setting it equal to the 0.12. So for the first solution, it's 0.3%. So that means we got to convert that to its decimal equivalent, which is going to be 0.003. And then we will multiply that number by the total grams for the solution, which is just X. That's something we don't know. We go through the same process for the second one. The 0.15% just gets translated into its decimal equivalent of 0.0015. And then that's just going to be multiplied by y, which is the total amount of the second solution. So now we have our system of equations. So what I recommend at this point is just go to Desmos. We're just going to basically type the two equations into Desmos and look where they intersect. Okay, so now that I've done that, notice I don't see anything on the screen. That's just because I have to zoom out. Okay, so here is the intersection point. We can click on it, 2040. That means 20 grams of the first one, the 0.3%, 40 grams of the second one, the 0.15%. Which one is it asking for? It's asking for the amount of the 0.15%. So that is Y. So the correct answer to this question would just be 40 grams. Now, I will also point out, technically, you could, of course, solve this by hand, probably using elimination. If you're going to do that, I probably won't go through the entire solution. I'll just probably skip some of the steps. What I would first do is I would multiply the bottom equation by 100 on both sides just to get rid of the decimals because it can be so much easier to work with whole numbers. So this basically turns into 30x plus 15y equals 1200. And then the way that I did it is I multiplied the top one then by negative 30. So that gave me negative 30x, negative 30y, and then negative 1800. This cancels out. Basically, you get negative 15y equals negative 600, y equals 40. Okay, so that's how you could do it by hand as well. Okay, the next question, you have a thing about a tree growing at a certain rate, but it's in but it's in terms of months, but they want to know the growth in terms of years, and they have a bunch of variables here. We have M and K and everything. So there's two ways you could do this one. First, I'll show you kind of the theoretical solution behind this, and then I will show you how you could solve it using picking numbers. So going to start off 33 centimeters every m months. Okay, so I just set up a ratio like this. Now, let's say we want to find the growth of the tree. So notice here in my original thing, growth is on top, right? 33 centimeters is growth, and this is basically time. So now if I want to find the growth, I'm just going to call that x, because you want to know the growth of the tree after k years. So down here is where you would put k years. But here is the thing that's tricky. Here's the thing that's confusing. In order to set these equal, you have to have the same units on both the top and the bottom. So the problem is right now on the left side and the bottom I have months, but on the right side I have years. So technically you have to take k years and you have to like basically convert that or represent that in terms of months. So the way you do that is it just turns into 12 times k months. So if you think about that, okay, basically it's like, just think about this little separate, unit conversion here. You have k years, right? We know that 1 year has 12 months. So now if you went through and multiplied this through, you would say, okay, k years is equivalent to or is the same as just 12 times k months. And you just think about it in your head, right? 5 years, if you want to find how many months that was, well, you just take 5 times 12 and you would get 60, right? Just multiplying the number of years, which is k, times 12. So now what I can do in the bottom here is I can just replace this with 12k, which is the number of months. Now I have the same units everywhere. So technically what I'm solving for is this right here. What is the growth that corresponds to k years? Or again, I changed it or converted that to 12k months. So now all you have to do is basically, you can either cross multiply or it's actually going to be quicker and easier just to multiply both sides by 12k because then you don't have to divide again. So in other words, 12k is going to cancel out. And then now on the left side here, we have 33 times 12. That becomes 396. We also have a k. And on the bottom, you have an m. Now we don't have any units in the answers, so like whatever, just ignore that for right now. So okay, ignore the centimeters, ignore the months. But this is the correct answer right here. It's letter C. Now, here is how you could do this by using the strategy of picking numbers. So what I said is, okay, I said 33 centimeters over 3 months. Okay, that means it's basically the equivalent of 11 centimeters per 1 month. And then I said, okay, let's let k equal 1 year. So in 1 year, we would expect the tree to grow how much? Well, if it's 11 centimeters in per month and 1 year is equal to, 12 months, well, just multiply that. 11 times 12, 132 centimeters is the total growth we would expect over 1 year. Okay, again, where I set m equal to 3 and I chose k equal to 1. Here's my m, here's my k. Now what I'm going to do is just go to the answer choices and plug in m and k, and I'm looking for the answer choice that will give me 132 as my answer. And it's going to be so much easier to do this by just defining m and k as 3 and 1 and then just typing in each thing. So this is answer choice A. That is obviously not correct. For answer choice B, notice here I can just switch m and k. Not correct, not 132. Next, answer choice C. Now I got to put k back up here, m down here. 132, this appears to be correct, and then you could just check answer choice D. 1188, not correct. Okay, so this is again how you could use picking numbers as an alternate solution method to solve this problem. Now I'm going to start going through the alternate solution methods from some of the August and October problems, again, as suggested by commenters on my channel, and the username of the commenter who suggested this method will be, basically will pop up on the screen in the video. So first we're going to August 2024, part 1 and question number 7. All right, so with this question, there's actually basically this is just kind of like a shortcut steps or shortcut method you could take. So you take 1 and you plug it into this function, and basically you could type in, the whole thing f of x, blah blah, evaluate it, and then if you do that, okay, you're going to get 12. Now this is not necessarily the new approach. However, what you can then do is just use a regression statement. Okay, so there's the function. Okay, there's our f of 1 equaling 12. And the reason, basically, the reason that this works is, notice on the left side, if you plug in 1 for x, well, 1 squared is just 1, and 1 times this is just 1. So on the left side, you get, plugging in 1 for x, just a over 6 plus b over 6 plus c over 6. Okay, so the whole shortcut alternate approach here is that this is equal to 12, and now we can do regression. And so the thing is, okay, technically here, notice it just gives you 72 just for A, and the others are 0, but that's fine. It's basically, it's the correct answer. A plus B plus C is still equal to 72. And even if you added in the x's, okay, like this. Now, here, if you do that, we do have to add the list and add the things. And so it gives us different values, but we still get 72. Okay, so notice here we get 72. If we have 2 numbers in our list, we still have 72. If we have 3, we still get 72. We have 4, you know what I'm saying? So you still get the same answer regardless of whichever method or whichever approach you want to take. So this is just kind of a shortcut way that leaves out a lot of the work if you look at like my previous solution in the video. Okay, so the next one is number 9, the one with the equilateral triangle. So the approach that was recommended by the commenter, again, username on the screen here. So it's basically, this height is 44. You say that each side here, you can a or x, whatever variable you want. It's the equilateral triangle, right? Basically, this is going to be a over 2. It's going to be a over 2 because the equilateral triangle gets cut, its height cuts it into 2 congruent triangles, 2 30, 60, 90 triangles. So essentially what you do is you use Pythagorean theorem, and you've got like a over 2 or x over 2, either one, squared, plus 44 squared is equal to a squared, the hypotenuse. You solve this for a. Then you multiply that by 3, and then you set that value equal to w root 3. And so to solve for w, you can just divide that value by root 3, and then that will give you your answer. So we can do this on Desmos. I won't bother doing this by hand. I mean, technically you can, but there's no reason to do it by hand because you don't get nice exact values. So we're going to go to Desmos anyways. So there's 2 ways you could do this. You could squared and there we go. And you could type the equation. Let me get rid of this. Okay, so you could type the equation and then, you know, you could get this here, this 50.807, or you could also put x1 and then technically make it a regression. The reason that you would do this is because you get a couple more decimal places here. Now, the other thing too is that if you do this by hand, so in other words, if you do the actual like manipulation out, you can actually get the exact value. So what I mean by that is you turn this into, and I'll just use whatever x is going forward here. Let's see, this is 1936 is x squared. So basically you get 1936 equals 3/4 x squared, and then you just multiply by 4/3 times 4/3, right? And then you're going to square root both sides. So the point is, if you now type in the square root of 4/3 times 1936, here is the full exact value, all right? So that's the value of x or a, you know, whatever in my diagram, all right? Like 50.8068, 50.8068. Now, you'd multiply that by 3, and you'd get some number. It's going to be like 152.42, whatever, approximately. And then, so that's your perimeter, you know, because that a or x is one side, and then multiply by 3 to get the total perimeter. Then that is equal to w root 3. So all I have to do now is divide this number by root 3, and that's going to give you your w. So the problem is, let's see here. So if I take the first value, 8068, and I multiply it by 3, okay, and now I'm going to divide. So here's the problem. Notice if I don't have the actual exact value, it gives me 87.999. So, I mean, probably on the test, you would realize, okay, well, if I try to enter this in, either technically truncating it, it'd be 87.99, but if you round it, it would be 88. So you probably figure out that it's really supposed to be 88, but you don't know for sure. However, if you take this and do the calculation with the exact value, so in other words, I take a and I multiply it by 3, and then I divide that by the square root of 3, see here, now it comes out to exactly 88, okay, which is the correct answer for this. So this is just an alternate approach, alternate method you could take, again, as suggested by one of the commenters on the video for it. Next, we're going to the August questions, part 2, number 4. So for this one, what you can technically do, again, this is not something I'd really ever seen before or thought of, is you can take the expression on the left. So this one's going to be done entirely in Desmos. Okay, we're going to type that in. And then we set this equal, and then I'm going to replace the letters on the right side with x and y. Okay, so it's basically graphed out a function here. And it wants to know what's the value of r plus b. But the problem is, notice there's like tons of points here. But the thing is, there are only a handful of points where r and p are basically integer values. That's really essentially what we're looking for. That's what you get when you solve it out. You get, 18 and 6. So what you add is this little command here. So this mod command basically takes the remainder, and it wants to set the remainder with x dividing it by 1 such that it's less than 0.001. So in other words, it's telling it to return only integer values. So you look at the points here. Let's just like zoom in. Now you can see it's only like finite points, right? It's not a curve. So like here is an integer, essentially an integer value of x. But what we need to do is look for both where x and y are both going to be integers. So in other words, we're looking for points that are exactly on the grid or intersection marks on the graph. So this is the correct answer, 18, 6. This one, okay, notice here technically it's undefined. That doesn't, so that's not going to be something. This one, again, it's okay, it's not exactly 16 or whatever. So therefore that one's not, an integer value. This one, again, there, not exactly an integer value. It's close, but not quite. So this was just an alternate approach. Don't know. I mean, guess this is something you could use if you're really struggling with a problem that's identical to this or come across this. But it is just another method that works as well. Okay, next up, same video, same set of problems, problem directly below it, problem number 5, suggested by the same user, again, named on the screen. So for this one, what you can actually do, and I didn't even think about this, is you can add the 2 points in and just do a regression and then evaluate the functions from the regression, and that's it. All right, so now if we've done that, notice it's given us values for A, B, and C. So all we have to do now technically to evaluate it, I mean, you could type x equals -4 and you could type x equals -10 and look for the intersection, but they're going to be some pretty large values. So it actually, I think, will be easier to just, type the function out. Basically, you're just going to type the exact same thing that you see in the line above. You're just not going to put x1. You're just going to put x. Notice I typed it correctly because they completely overlap. In other words, I turn this off. Oh, there's the original. I turn this off. Nothing changes. So that's good. All right, and then so now I can just do the f of -4 plus f -10. 532, same answer, much quicker, much easier approach than like trying to figure out the theory behind it. So this is just an alternate approach. Thank you again to the commenter who suggested this method. So just keep that in mind, going forward. Now, next we're going to part 3 of the August, basically problem set, the third video. First we are looking at, let's see here, question number 3, the one with the formula here. So this is just a slightly different method than the approach that I had with like the horizontal lines, but maybe you find this easier, to do or to follow. So basically, the first thing is just defining a letter as 23, and that's basically going to take care of the top here. So in other words, this is really just like, say, whatever, like there was an A on top here, that's whatever representing the 23. Okay, then what I'm going to do is then we can go ahead and we can type in the right side. And then after that, we're going to add sliders. That should be A, should be S. Okay, so add some sliders for P, R, and S. And you can pick whatever numbers you want. It doesn't matter. I'll just go through the numbers that were given in the comment, which is basically 2, 3, and 4. You could also type those in, by the way. You do not have to move it using the sliders. So what this tells me is the right side of this equation, when I pick these values for P, R, and S, is equal to 24.916, basically repeating. Okay? So now, essentially, what you're going to do is, if you notice, on the left side, it's like A over Q, or 23 over Q, is equal to 24.916, blah, 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 blah. So if you just rearrange this, just cross multiply and get the Q up here, and then divide by this on both sides, basically that will give you the value for Q. So we just go to Desmos and we get Q equals, we can put A, and now here, I'll just define this as whatever, B, and then I can just type that and use the exact value. Okay, so this is what Q is equal to, 0.92307 approximately. Okay, so now you would just go through and you would type all the answer choices and you would just see which answer choice gives you this value of 0.92307. Okay, so you're not looking for lines on a graph, you're instead looking for, a value from all the various expressions. So if I remember this, the correct answer plus QR plus R T, no. It's PRS over PR plus SR plus RT. Let's see here. No, that's not correct. Okay. Sorry, I forgot that because we have the 23, which I define as A in here, that is technically in all of the answer choices. But this is still not coming out correct. Okay, just realized I have the same thing listed twice in here. That's what the issue is. We need PR, we need R and S, and we need P and S. There we go. This is the correct answer choice if you solve this all out. And now notice the number matches. Okay, so again, what you would do is after going through these steps, you would type out the various answer choices and you would see which one gives you the exact same value as you get for Q in an earlier step. All right, next up we have number 6 from this same test. Okay, this is the tangent one. So alternate method you could use to solve this is, again, you could just type tangent of, square root 3 divided by 3. Make sure you're in radians. Need to be in radians, which we are. Okay, good. And now what you could do, sorry. We need the equation. We need tan x equals root 3 over 3. There we go. Sorry, to get the solutions for the values of x, again, in radians, that give you root 3 over 3 as the value and take the tangent of it. Okay, now what you do is you type in each of the answer choices, and then what we're going to do is we're going to look for them on the graph and see, do these overlap the vertical lines in our graph anywhere? So notice the first one is like 31.9, so let's scroll out here. Okay, so let me actually, yes, do it this way so that this is what we have to do so we get vertical lines. Can't just type the value, but technically, yeah, there we go. Okay, so let me take each of these off. So notice this one perfectly overlaps a purple line, which is, purple lines are the solutions. So yes, this is a solution to that equation because it overlaps it perfectly. Okay, so number 1 is correct. Now this one, it's way over at negative 37. So let's scroll out here and now let's zoom in. All right, so when I highlight this one, does this overlap one of the purple lines? Yes, hopefully you notice that it does. So that tells me that 2 is also a solution. Now let's go back to the right and look at C. So when I go in, notice when I click this one does not overlap. That tells me this is not a solution to the equation, so 3 does not work. It's basically 1 and 2 only. Okay, now we are moving to some questions from the October 2024 videos. The first one is from part 1 or video 1, and it is question number 4. So on this one, one thing you can do, which can basically like cut down on the algebra a little bit, is first of all, if you notice that if you plug in k for x, or in other words, if you notice that when x equals k, you're going to get a 0 here and a 0, and 0 equals 0. Therefore, this is a solution or a root. And so you can get the other solution or the other root by basically dividing by x minus k. And then what will happen is that'll cancel out one of those expressions on the left, and you'll get this. Then if you solve this equation for x, you get 2k minus 5a. So now we have our two roots or our two solutions. One of them is this, the other one is this. So if we add these together for the sum of the roots and set that equal to 3k plus 29, so 3k minus 5a equals 3k plus 29. 3k's drop out. Negative 5a equals 29. Notice here again, we get the exact same answer that I did in the previous method, but basically the algebra is a lot easier and a lot shorter. Okay, so again, thank you to the commenter who pointed out this method. Next up, it's on to basically video part 3. So first I'm going to look at problem number 1, the very first problem. Here, where you have this right triangle. So here is possibly a much quicker, easier, simpler solution to understand this. So here we have cosine A, here we have angle A, excuse me, and we know the cosine, which is adjacent over hypotenuse, is 3 over 5. So you probably already recognize that this side is going to be 4, but if you didn't, you could do 3 squared plus x squared equals 5 squared, 9 plus x squared equals 25, x squared equals 16, x equals 4, square root both sides. Now that you have this, what you can do is just set up a proportion, okay? You want to find AB here, right? So essentially, this BC here we know is 290. So you can say, okay, AB to BC. We know that the ratio of AB to BC simplifies to 3 over 4, but in terms of the actual side lengths, we know that it's like x over 290. Because we're told BC is 290. So now you just solve this. Again, you can multiply by 290 on both sides, or you can cross multiply. But, you just end up doing 290 times 3 divided by 4, and you get the same answer, 217.5. So this is probably a simpler, quicker, easier way to think about the problem. Rather than like some of the methods I went through in the original video. Next up is question number 8. So we'll scroll down here. Okay, so for this question, basically what you can do is just entirely using Desmos, you can do the following. Again, this is not something that I had used frequently or thought about, but I'm going to define S as the solution here that you're given. Okay, the negative 4 plus square root 544 over 24, okay? So just this thing, I'm just defining this, whatever, to be S. And then what I'm going to do is I'm going to take the equation. I'm using S instead of W. You could use W, like whatever's fine, okay, with the C. And I'm going to do a regression statement and basically set it, equal to 0. So it's basically saying if this left side, when S is this value equals 0, like what does C have to be? And it just solves it right here, and it gives us the exact answer we got before of negative 11. Okay? So again, I defined the letter in the equation, whatever you want to use, S or W, whatever, as the given solution, and then I took that equation, regressed it to equal 0, and it basically found, what the missing value of C is. So in other words, really what you're doing is, it's like you're taking this and you're plugging it in for, say, W here and here, and then squaring this out, multiplying it by 12, multiplying it by 4, combining all that stuff together, and then solving the equation for C. That's really what you're doing. It's just that Desmos will do that all for you, in just one step, basically. All right, then last question number 10. So this is an alternate solution method. Again, this will hopefully be a little shorter, a little easier to understand than possibly the original method that I went through. So this right here, okay, we know is 30 degrees. Again, AB, this whole side is 58. And the other stuff will come in, some of the other stuff will come into play a little bit later. So notice down here, this is perpendicular. Okay, basically you have a 30, 60, 90 triangle. Okay, so the sine of 30 here, 30 degrees, sine of 30 is equal to OF opposite over OA, hypotenuse. Sine of 30 is also equal to 1/2. Okay, you can just do that in Desmos if you don't have it memorized. So if you rearrange this, the side OF here is equal to basically OA over 2. Now, OA is also equal to OB because that's given information right here. Okay? Or an alternate way you could also rearrange this is you could say OA is equal to 2 times OF, just multiply by 2 on both sides. So what that means is if this is X, right, then OA would be equal to 2X. Well, that's just 30, 60, 90 triangle properties, right? Short leg to hypotenuse, which means this is also equal to 2X. Now, here's what you do, and this is the whole key to the whole problem. If you look at BO, if you look at the top triangle, okay, BDE, specifically look at the height here, BO. That is, say, 2X. Then you look at the large overall triangle, BAC, okay, and you look at this. This whole thing here is 3X. That means the ratio of the small triangle to the large, again, so small triangle to large triangle is basically 2X to 3X, or really it's just 2 to 3. The X part is irrelevant. It's the 2 to 3 part is essentially what we're concerned with. So what that means is any side in the small triangle is going to be equal to any is going to have a ratio of 2 to 3 to any side in the large triangle. So AB is 58, BC is also 58. Told AB and BC are congruent. All right. So small to large ratio is 2 to 3. So small triangle side is BE. That's what we're trying to find. Large triangle side is 58. Okay, I'm comparing this to its corresponding side here in the large. And again, I just determined the ratio is 2 to 3. So now you can just solve this for BE, multiply by 58. 58 times 2, 116 over 3. We get the same answer that I got working it out, using the other approach, the other method, but this one is, much shorter, much easier, fewer steps. But basically what you're doing is essentially determining the ratio of the small triangle on top to the large overall triangle because they are similar triangles. And then that ratio is what allows you to figure out, BE in relation to BC, and therefore solving for BE or getting the answer. Okay. I hope you enjoyed this video. Again, it went through 2 new problems that I had previously gathered from the August 2024 exams, and it also covered some alternate solution methods to the October 2024 problems. If you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications. Otherwise, leave any comments or feedback below. And should be back here soon with some more problems from the November 2024 exams.